All right, hopefully the last video. Now on these, you've got several choices. Got to get myself a straight edge compass. All right, for the next one. For each graph, find A, B, the length. This is find the length and the coordinates of the midpoint. So the length here, I'm going to use the distance formula. The difference between my x's is 4. The difference between my x's is 2. The difference between my y's is 4. So I'll have 2 squared plus 4 squared. Just like this one will be the square root of 20. This one, rather, will be the square root of 20 or 2 square roots of 5. 1, 2, 3, 4, 1, 2. All right. And then, so that's my distance between the 2 points. And the midpoint, dangerous. So we're at 1, negative 1, and we are at negative 1, 3. Now the reason I'm not just going to grab this, I'm pretty sure it's 0, 1 over 2. But you really don't want to try pulling this off a graph. You really want to calculate it by hand. So just in case the fraction gets a little weird on you, you're not stuck out. So our x's, I've got negative 1 plus 1 over 2, that's going to be 0. And then I have 3 minus 1 over 2, so that's 2 over 2. It's going to say it's right here at positive 1. And that's why you want to do it by hand. It kind of looks like it's hidden in the middle at that 1/2, but you do the math and you're going to get that point and it's going to be accurate rather than trying to guess from a graph. Make sure we get those points. Now this one, same thing. Looking for the difference in my x's, 1, 2, 3, 4, 5, 6. So going back to my formula, the difference in my x's is 6. The difference in my y's, 1, 2, 3, 4, 5, 6, 7, 8. Difference in my y's is 8. So I've got 36 plus 64, that's the square root of 100. So my distance is 10. And then again, it looks like I can pull this midpoint right here straight from the graph, and that would be 2, 1, and it's probably going to be okay, or 1, 2 rather, and that's probably going to be fine. But you always want to go in and check, especially when you're dealing with tests and quizzes where, you know, a casual mistake for 1, 2, 3, 4, 5, 6, where a casual mistake costs you a whole bunch of points. You're going to want to make sure that you're accurate. So I've got negative 2 plus 4, positive 2, divided by 2, 1. I've got negative 2 plus 6, positive 4, divided by 2, 2. So it's always handy to check and make sure your math works out just in case there's a weird fraction and it's not exactly where you think of. Constructions. Copy this angle using only your straight edge. So the first thing I'm going to do is draw myself a line, and I'm going to go through the steps that I've copied. So the first thing I've done is copy this line. The second thing I'm going to do, I need to get myself an arc to use as a measuring device. So I've got this right here, and I will have this right here. So now I have copied this too, and we'll call this one B over here. So got this, got my arc copied. What I need to know now is where this arc and this other ray cross. How I'm going to do that is I'm going to put my dot, I'm going to put my pokey rather, where it goes, where it crosses the first line, because I know where that is, and I have to measure out to where it crosses the second ray. So I've got that measured, I put it right here, draw my arc, and now, most important, I have my third copy. I've got that point where those two intersect. Boom. And now I have copied it. Alright, bisect the angle. I need a point that's the same distance away from here as it is from here. You'll notice I already have one, which is the vertex, because these two are going to be congruent. So I get an arc, I get another arc, and where these two cross, it is the same distance away from these 2 points. Just like the vertex is the same distance away. If I connect the 2 dots, I will find the line where all the points are the same distance away from both rays. That will be the line that bisects the angle. Looks real good. All right. construct the bisector of the segment using a straight edge and a compass. So the first thing I'm going to do is drop down. I'm going to get a little bit more than half with my compass and make a big sweeping arc. These are all the points that are the same distance away from this point. Without changing the length of my compass, these again are all the points that are the same distance away from this other point. So the two places where they cross denote where they are the same distance away from both points. And that line will be your bisector. All right, these are all the points that are the same distance away from both points. And when they intersect that line, it'll be the bisector because it's the same distance away from your endpoints. Two angles form a linear pair. The measure of one is 5 times the measure of the angle. So I know that x plus my other angle is 180, and it's 5 times larger than my original. So this is x and 5x. That means 6x is 180, x is 30. You'll notice they ask you for the measure of each angle. So 30 is my x, 150 would be 5 times that. And I'm going to put my little degree symbols in because I want to be fancy. The measure of one angle is 24 degrees greater than the measure of its complement. So x plus that other angle is 90. And x, we're going to call x is the first one, so the measure of one angle, x, it's 24 degrees bigger than the other one. So if I took 24 degrees away from it, that would be the measure of the other one. I've got 2x now is equal to 114. When I add that 24 to the other side, x is going to be equal to 57. And then if I take 24 of that, my other angle is going to be 33. Yeah. And those two will add up to be my two complements, my 90-degree angle. All right, we've got a wooden fence, probably going to need to grab a calculator, and it's 42 by 80. They want to know the perimeter, and they want to know how much this fence is going to cost. So my perimeter is pretty easy. I have a 42 side, I've got an 80 side, so 112 times, or 122 rather, times 2, 244 meters of fencing is necessary. It's going to cost $29 a meter. So I have 29 times 244, 7076, and then my dollar sign is handily right there. Find the circumference and area of the circles. Now circumference, 2 pi r or pi d, if you want to use pi d, sometimes it's more advantageous. And then my area is pi r squared, always r squared. So on this one, I'm going to use the pi d, 15 pi is my circumference. And then my area is going to be the radius, which is going to be 7.5 squared. So I'll have 7.5 squared, going to punch that out in my calculator real quick. And I've got 56.25 pi r squared is equal to the area. And we're going to throw in a meters and a meters squared in there. Can't forget those units. On this one, same thing, 2 pi r, so 14 pi will be my circumference. And then pi r squared, 49 pi will be my area. Again, this is meters squared. Don't want to forget those handy units. And that's going to be it for this one.